Okay, welcome to another final Algebra 2 final exam review. Um, Again, following along, this is number 12 on the packet. Number 12 on the packet, and this particular problem is about rational exponent and radical functions. This is also a more recent topic that many of you had have reviewed already and gone over. So part A, start with part A, f of x is equal to square root of x plus 3 minus 2. Now this is taking advantage of what you know of. Say, for example, if f of x is equal to square root of x, we know that this graph look like something like this. It's a very unique graph, right? No negative values, because you can have negative inside the radical. But we also know that if you have a number inside the radical with with x, it is typically minus a positive value. So right now, if you have x plus 3, that means it is minus a negative value. So the 3 means that it will move what you have here, this graph, standard graph, to the left by 3 units, right? And then this one, right, this is outside radical. This will move the graph up and down. So minus 2, that means down by 2 units. So that means your graph, right, your graph is going to move 1, 2, 3, negative 3 this way, and then 1, 2, negative 2 down this way, and that becomes your starting point. And if that's the starting point, then that's going to be your graph looking like this. So the domain is very simple. There's nothing past negative 3, but does include negative 3. So your graph, your domain is negative 3 bracket, which means it's equal to negative 3, and then goes all the way to infinity, parenthesis, because infinity is not the destination, so you have to do a parenthesis. Range, as you can see, it starts from negative 2, go all the way up, and it does include negative 2. So it's bracket, negative 2, and then infinity. So there you have it. That's part A. Part B, here you have it. You have a rational exponent question, right? So you got 2x plus 3 to the 2/3 power equal to 9. Now this 2/3 power is a problem, right? It's the exponent that traps everything inside that parenthesis. You cannot distribute the exponent. That's just not how it works. It's not mathematical. So we had to somehow get rid of it in order to move what's inside the parenthesis around. And so one way to do that is you can take both sides of the equation and up to a particular exponent. So I'll take this whole thing and raise it up by to an exponent of 3 half power. 3 half power. So if you do it on one side of the equation, you gotta do it on the other side of the equation. By doing so, power to a power, right? We take advantage of this idea that if you have x to the a to the b power, you can simply say it's a x to the a times b. Right, that's the property that we're taking advantage of doing. So then if we do that, we end up with 2x plus 3, 2/3, parenthesis, 2/3 times 3 half, right? So that just means that's 1, right? So it's parentheses, so it's power to the 1 power. So then this 2x plus 3 is free from the trapping of the exponent, right? And then 9 to the 3 half. Now, 9 to the 3 half power, right? The half power, right? 1 half power is the square root. So 9 to the 1 half power is square root of 9, which is 3. But then there's a 3/2, that's the 3 of the 3/2 power. That 3 is cube. So then it's 3 cube. So 3 cube is 27. Okay? So then we end up with 2x is equal to 24. Then x is equal to 12. Now we're gonna check and see if it's correct or not, right? So check. Make sure we're checking for check the answer. So 2 times 12 plus 3 to the power of 2/3. The big question is, does it equal to 9? So let's take a look at it. This is 2 times 12 is 24. 24 plus 3 is 27. So it's 27 to the power of 2/3, right? Is it equal to 9? Well, 27 and then the 1/3 power is cube root. So that's 3. 3 squared is 9. So 9 is indeed 9. So it checked out. So I go ahead and box x equal to 12 as my answer. Okay, lastly, part C, solving for radical equation. So radical equation, we got square root of 3x plus 1 minus square root of x plus 4 is equal to 1. Now, typically, if you have a radical equation, and you only have one radical on one side of the equation, or you have one radical on both sides of the equation, each side will have a radical, then you can just square on both sides of the equation, and that's the easiest thing. The problem right now is you have two radicals on one side of the equation. If you square that, imagine that you square something with two terms, you're going to have a cross term, right? You're going to have two other terms squared, but in the middle term you had a cross term. That cross term is not going to help get you out of the square root dilemma. So one simple way of doing this is move this equation onto the other side, right? So we end up with square root of 3x plus 1 is equal to 1 plus square root of x plus 4. And then this is when we can square on both sides. So let's see what we have here. We end up with 3x plus 1. And then this one we gotta factor it out. So we end up with 1 squared plus 2 times square root of x plus 4 and then plus square root of x plus 4 squared, which is x plus 4. So now I can go ahead and simplify this by moving all the non-square term, square root term over here. So I will end up with 3x plus 1, and then I'll bring the 1 over here minus 1, bring the x over here minus x, bring the 4 over here minus 4, and we end up with equal to 2 square root of x plus 4. So 1 and negative 1 cancel out. 3x minus x is 2x. 2x minus 4 is equal to 2 square root of x plus 4. I can further divide by 2 on both sides. So I end up with x minus 2, x minus 2 is equal to square root of x plus 4. And in this case, then I can go ahead and square on both sides again, because that way I can get rid of the square root over here. So I end up with x squared minus 4x plus 4. Over here is x plus 4. So further simplify this a bit more. I end up with x squared, right? Negative 4x minus x is negative 5x. And then 4 and 4 cancel out, becomes 0. So it's x squared minus 5x equal to 0. So I will factor out x, and I get x minus 5 is equal to 0. So I end up with x equal to 0. X is equal to 5. I have these two answers. But I must check my answers, because oftentimes when I square, right, initially when I have equation, which is a root equation, when you square, you actually naturally introduce new extraneous solutions. Because when you square on both sides of the equation, you fundamentally change the nature of the equation. So you have to go back and check. So let's check. And check means you take the solution you found and put it back into the original, right? So let's start with x equal to 0. X equal to 0, put it back into the original equation. Square root of 3 times 0 plus 1 minus square root of 0 plus 4. Is it gonna be 1? Well, let's see. This becomes square root of 1, which is 1, minus square root of 4 is equal to 1. Well, 1 minus 2, this is negative 1, which is not equal to 1. So we know that x equal to 0 is not the answer. So we're going to cross that out. Now let's just check. I'm pretty confident that x equal to 5 is indeed the answer. But what do I know, right? So let's check. X is equal to 5. So square root of 3 times 5 plus 1 minus square root of 5 plus 4. The question is equal to 1. Well, over here, we end up with 15, 3 times 5, 15 plus 1, 16. Square root of 16 is 4. Minus square root of 9, which is 3. 4 minus 3 is indeed 1. So yeah, x is equal to 5. Alright, so there you go. This is a three-part problem on radical and rational exponent types of problem. Okay, all right. See you next video for another problem.